In this video, I want to start with the sizing of the circuit breakers. First, we size the circuit breaker and then move on the trip unit to set the function, long time, instantaneous, and ground fault. For sizing of the circuit breaker, NEC has a rule, has a requirement, 125%. NEC states here, NEC 210.1020A applied for overcurrent protection. It says, for a continuous load, the circuit breaker must be designed at least 125% of load current. Here, some people have a mistake and they said let's look at the, okay. Here it says 125% of continuous load. This is the screenshot of the NEC standard. 120% of the continuous load. But what is continuous load for the motors? Let's discuss about two concepts. Full load current, rated current. There is a 2 ampere for motors. What is rated current? What is full load current, FLA? The rated current written on the nameplate of the motors, or you can find it in a specification sheet. But FLA, you can find it in the design document, or turn on the motor while coupled, for example, with the pump, open the valve completely 100% and measure the current. When you measure the current, it gives you full load current, FLA of the motors, not rated FLA. Why FLA is less than the rated of the motors? When the pump is designed, when the mechanical engineer specify a load, for example, 210 kilowatt, specify a load 210 kilowatt. He gives this information to electrical engineer or electrical designer. Electrical designer or electrical engineer start to sizing of the motors. But what the sizing of the motors? He considers a margin for a motors. That means he sized motor 10 to 30%, sometimes 40% more than the load that mechanical engineer specified. If motor properly sized, the rated of the motor bigger than rated of the pump or fan. He considers 10% to 30%, sometimes 40% as margin. For example, we have 250 kilowatt motors. Definitely the pump is lower than 250 kilowatt. The current on the shaft gives you full load current, not rated current. That's the difference between rated current and full load current. Or also you can get the rated current with the formula P equal root of 2 root of 3 VI cosine phi multiple efficiency. You can derive rated current from this formula. For example, for motors with with 250 kilowatt, it gives you 293 amp. This is the motor rated current. Okay, we figure out what is a rated current and what is the FLA current. Therefore, here is 125% of the load current. That means a rated current. We figure out the rated current is 293, exactly driven by formula or written on nameplate. Applying this rule, 125% of the rule, 1.25 multiple 293, it gives us 366. Okay, we don't have the breaker with this size. We round up to next standard size, which means next standard rating is 400 amp. We size the breaker 400 amp MCCB. Now we size the circuit breakers. Let's talk about 80% rated vs 100 rated circuit breakers. Let's talk about this topic, it's really important. 80% rated breaker versus 100 rated breakers. 80% means can carry only 80% of the rated current continuously. For example, if breaker it's written 80% rated, which means can carry only 80% of rated current continuously. For our breaker is 400 amp and 80% rated. It means, let's see, 400 multiple 80. That means our breaker can handle 320 amp continuously according to NEC standard. If breaker is 400 and 100 rated, it means breaker can continuous and handle current 400 amp, not 320 amp, because now it is 100 rated. Let's look at this. Okay, let's add this point. Continuous load means 3 hours or more as defined by NEC. This website, Schneider, the best source for discussion. What is difference between 80% rated breaker and 100 rated breakers? 80% can only continuously defined as 3 hours or more by NEC standard at the 80% of continuous current rating. Here is an example. It says if it's breaker 150 amp, dial to 100 because the breaker is 80 rated. If it's 100 rated circuit breakers, you can apply up to 100 of the current rating continuously. Here's some example of the breaker with 100 rated. This is just for Schneider. Power pack H frame with a special suffix, power pack J frame, L frame, and so on. Now let's look at our breakers. I select a breaker here ABB S5L. I don't know what is this, is 80% or 100%. I go to the document, I download the document. The document say 400 amp, 100 rated, UL rated. That means this breaker can handle 400 amp continuously. If it's written here 80%, it can handle 320 amp continuously. This is a really important concept, and I have to say majority of breaker is 80% rated, 80%. But the best source is goes to the document and see the document. Then you figure out this is 80% or 100%. Okay, we discussed about this one. Now let's back to the trip unit. Now we size the circuit breaker. Let's talk about the trip unit. Trip device. Okay, this breaker is LSIG. First L. In low voltage we say long time or overload. In an ANSI code is 49. In medium voltage we say overload, but in low voltage we say long time. There is a one concept, the same concept, but a different name. Short time. Short time means DMT, definite minimum time. Low set. The function 50 with the delay. In medium voltage we say DMT. In low voltage we say short time. This is for coordination. We don't apply for motor protection. We don't need it. Instantaneous. Instantaneous function 50. Delay is 0. Without any delay. Instantaneous or function 50 in ANSI code. Today I want to first talk about the long time. For long time pickup current typically between 1.05 to 1.25 of FLA. But some people do not access to FLA. You can either find it in the design document or go to the site and measure the current while motor is in operation and the valve is completely open. I'm talking about, for example, a pump. And you measure the current, that is FLA. But for simplest and safest approach, we consider I rated equal I pickup of overload. This is easy way. That means you have I rated of the motors 293. This is exactly pickup of long time or overload. But how to set this current to 293 on the trip unit? We say 293 over 400, the rating of the circuit breakers. Multiple IN, again the size of circuit breakers 400. It gives us 0.73 multiple IN. Let's look at the trip unit. If you see the trip unit started 40%, goes up to 70 and goes to 75. 0.75. But the number we acquired is 0.73. We round up 73 to next standard setting. Do not round down to 0.70. Goes round up to 0.75. It gives you 300, because if you multiple 0.75 multiple 400, let's do it. 400 multiple 1, 5, 300. This is the pickup of overload or long time. The overload has a band long time. There is a curve. Curve is 5 seconds, 10 seconds, 15 seconds, 20 seconds, 25 seconds, and sometimes 30 seconds. This is curve A. This is a 5 second. The best way to figure out, you select the best curve is to draw out, is to see it in the TCC page. I provided here. This is NEC. Okay, here. If you see here, the sensor is 400 breakers, 0.75, 300 amp, and LT band is curve A. The most important thing is this curve doesn't intersect TCC of motors. That is correct. That means allow to TCC, allow to motor to operating. Let's review previous video. This is in rush point. We mentioned this is in rush point. It took a time around 20 milliseconds. This is a starting time, starting current, and this is a starting time. If you see here is a second. After in rush current, we have in rush. After the in rush, we have a starting current. This is time of starting, and then goes to the operating part. Operating, that means a normal operation. And for instantaneous pickup, let's discuss about instantaneous function in the next video. In the next video, I explain about, just let me add this point. Short time, we do not need to motor protection. We do not need it. In next video, I explain how to set instantaneous function. You can see a few number here, but there is a concept behind this, and I look forward your feedback. Please comment and let me know what you think. And if you enjoyed the video, please subscribe and like it. Thank you.